So we've been looking at data and statistics like mean, median, mode, and range. And we're going to look at box and whisker plots, which are a really neat pictorial way of representing that data. Box and whisker plots split up the data into quartiles. And here we have the box in the middle, which represents the middle range, or the 50% in the middle. And we also call that the interquartile range because it's in the inside set of the data. In a box and whisker plot, all the data is represented and split into quartiles or fourths, and each quartile actually represents the same amount of data, and it just shows how spread out the data is. Cute, huh? Box and whisker. One of the many benefits of a box and whisker plot is that you can compare data. Like here, salesperson Angela to salesperson Carl, and you can see how the data compares. Like the median for Carl is higher than the median for Angela. His interquartile range, you can compare them. You compare the extremes for each person. So it looks like Carl consistently sells more computers than Angela does. Keep in mind, once again, that all four quartiles represent 25% of the data. So here's 25%, the first quartile. The inner quartile is the middle 50%, and then here's the upper 25%. So here's another way of looking at the quartiles and seeing that they're split into 25% or fourths. And again, the inner quartile range, is that middle 50%. In order to construct or make a box and whisker plot from a set of data, we use a 5-number summary. So we have the lower extreme, or the smallest, the upper extreme, which is the greatest. We find the middle, and then we find the middle of the bottom half, called the lower quartile, and the middle of the upper half, called the upper quartile. So step number 1 in making your own box and whisker plot is to look at your data and put it in numerical order, like this one here. Once it's in numerical order, you can start crossing off the ends to find the middle. So here I eliminated 4 from both ends and found that there are 2 numbers that lie right in the middle. So I'm going to find the median of those 2 numbers. So 12 plus 14 is 26, divided by 2, because there are 2 numbers we added, is 13. Also, if you think about it, 13 just falls right in the center between 12 and 14. And remember that the median splits our data into 2 halves. Right here we could split it, and we have half the data in the lower half and half the data in the upper half. So you can quickly find the lower extreme, which is the smallest, and the upper extreme, which is the greatest data in your set. And the range would be then to find the difference between them. So 21 take away 5 is 16. So there's a range of numbers in our data set of 16. Now we're going to find the median or middle of the lower 50% and of the upper 50%. So for this section here, because it's split in half, we're going to find the middle of that, which will actually split all of our data into fourths. So if there's 2 numbers in the middle, we're going to split our half right in between the 2 numbers. So with our data split into halves, I'm going to cross off from both ends. I crossed off 2 on each end, leaving 7 right in the middle. So the lower quartile is 7. Do the same thing for the upper half, or upper 50%. I crossed off 2 on each end, found 17 right in the middle for the upper quartile. It's the lower and upper quartile that's going to make the box of our box and whisker plot. And that would be our middle 50%, or called interquartile range, because it's in the inside 50%. So to find the range of numbers that fall in the box, you subtract 17, subtract 7 is 10. The next step is to take our 5-number summary and plot them up on a number line. So your lower extreme, your upper extreme, your median, your lower quartile, that's 7, the upper quartile is 17. And then we put a box around the lower quartile and upper quartile, like so. And next we draw a line for the median, and missing down here, we need the whiskers. And the whiskers extend from the upper and lower quartile out to the extremes. Remember that to find the interquartile range, you're subtracting the upper quartile and the lower quartile. So that's the range of numbers in the middle 50%. Also remember that every quartile is represented from that data, and that they all contain the same amount of data points, but it shows how spread out the data is. Okay, here's another set of data that we're going to make together on your handout. The difference in this one is that there's an odd amount of data. So when we cross off to find the median, we end up with only one number in the middle. So the median here is 16. So go ahead on your handout, find the lower extreme and the upper extreme. Of course, making sure that your data was listed in numerical order first. But then we can easily see that the smallest number is 10 and the greatest is 22. So one difference here when finding the lower quartile and upper quartile is that since we only had one number in the middle, we're not going to use that as part of the two halves. And we're just looking at this lower section and this upper section. And so we can cross off to find the middle. So our lower quartile is 13. Do the same for the upper. Cross off there, one on each end, and our upper quartile is 20. Okay, so now that you have your 5-number summary, you're ready to plot this on a number line. Because our smallest is 10 and our greatest is 22, that helps you decide what numbers your number line should include. And I decided to go on this one as an interval of 2. Alright, pause the video and draw your box and whisker plot. So once you have your 5-number summary plotted on your number line, then you're going to box the lower quartile and the upper quartile, draw a line for your median. Remember that's your interquartile range, or the middle 50%. And then we extend a line out from the box to the lower and upper extremes for your whiskers. So remember, 25% of the data falls in each of these quartiles. And we can find the interquartile range by subtracting your upper quartile of 20 and your lower quartile of 13 to get 7. So our middle 50% has a range of 7. And that's how you make a box and whisker plot, keeping in mind that the nice thing about them is that they're a pictorial representation, and that they show how the data is spread out, and that you can use box and whisker plots to compare sets of data.